Hi everyone! Today we're going to study bit operations. Let's begin by defining bit. A bit is a symbol with the possible values, namely 0 and 1. Computers represent information using bits. A bit can be used to represent a truth value of a proposition. Since there are two truth values, true represented by T and false represented by F, we will use a 1 bit to represent the true value and a 0 bit to represent the false value. Let us define Boolean variable. A variable is called a Boolean variable if its value is either true or false. We normally give letters like P or Q to represent the Boolean variable. Consequently, a Boolean variable can be represented by bits. Let's go now to bit operations. Computer bit operations correspond to logical connections. We studied the symbols here. The first symbol is for negation operation, and we read this as not. The second symbol is for disjunction. We read this as or. The next symbol is for conjunction, and we read this as and. The next symbol is for exclusive OR operation, and we read this as XOR. The next symbol is for conditional operation. We read this as implies. The last symbol here is for biconditional operation, and we read this as if and only if. Let us recall our truth values. We have here proposition P and proposition Q. With all the values for the P, we write T, T, F, F. For the Q, T, F, T, F. These are all the possible combinations of T and F for the two propositions. Let us show the negation of these propositions. So not P and not Q are here. When P is T, not P is F. When P is F, not P is T. Also for the Q, when Q is T, not Q is F. When Q is F, not Q is T, respectively. Next is the P and Q. For this operation, the value is only T when the two propositions are T values. See here, T and T is T, T and F is F, F and T is F, F and F is F. Next, P or Q. This is only false when both of P and Q are false. T or T is T, T or F is T, F or T is T, F or F is F. Next, P XOR Q. The values will be T if exactly one of the two propositions is T. So we have here T XOR T is F. T XOR F is T. F XOR T is T. F XOR F is F. Next, P implies Q. This is always true except when the P is T and the Q is F. So we see here T implies T is T. T implies F is F. F implies T is T. F implies F is T. The last one is the biconditional P if and only if Q. This is only true if both truth values of the two propositions are the same, both true and both false. So T if and only if T is T. T if and only if F is F. F if and only if T is F. F if and only if F is T. Now, by replacing T with 1 and F with 0, we obtain the corresponding bit operations. So it means, let's have the P and Q. So the values now are 1, 1, 0, 0. For the Q, 1, 0, 1, 0. For not P and not Q, we will change 1 into 0 or 0 into 1, respectively. Next, P and Q. So 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. The value is only 1 when both P and Q are 1. Next, P or Q. The values are always 1 except when both P and Q are zeros. So 1 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. 0 or 0 is 0. P XOR Q. The value will be 1 if exactly one of P and Q is 1. So 1 XOR 1 is 0. 1 XOR 0 is 1. 0 XOR 1 is 1. 0 XOR 0 is 0. P implies Q. The values will always be 1 except when P is 1 and Q is 0. So 1 implies 1 is 1. 1 implies 0 is 0. 0 implies 1 is 1. 0 implies 0 is 1. P if and only if Q. The value will be 1 if both P and Q here have the same values, both 1 or both 0. So 1 if and only if 1 is 1. 1 if and only if 0 is 0. 0 if and only if 1 is 0. 0 if and only if 0 is 1. These are now the bit operations. I hope you learned something from this video. See you again next time.